Welcome back to che205. Today I'll be talking about rank of a matrix and how we can use that rank to answer whether the system has a unique solution or it has infinite solution or there's no solution. This is section 374 of the textbook on page 68. Alright, so by definition, the rank of a matrix is defined as the number of non-zero singular values when you do the singular value decomposition. And to do the singular value decomposition, you can use the matrix package. That's one way to do it. Another way is to use Gauss elimination, which I don't recommend. In case you cannot use matrix package, then the best way would be using Gauss elimination, and by doing that you can find the number of non-zero rows or columns, which would be identical to the rank. But for now, let's use matrix package. So I'm going to start with an example that would be similar to example 3.3. Alright, so let's open a spreadsheet, and to make it more generic, let me just clear this up and start with an example. Okay, so we're going to look at how we can use the rank of a matrix to check whether there is a solution, there is a unique solution, or there is infinite number of solutions. Okay. So the first example is going to be matrix like this, 1, 1, 1, and then second row is 1, 1, 1. So this is identical to this is identical to a system like 1 times x plus 1 times y plus 1 times z. That's equal to, let's say 3, and then I have 1 times x plus 1 times y plus 1 times z, that's equal to 4. I have a system with two equations, should be plus, increase the font, I think 14 should be good. I have a system with two equations, 1x plus 1y plus 1 is equal to 3, 1x plus 1y plus 1 is equal to 4. And we can see clearly that there is no solution to the system because the left-hand side of these equations are identical, the right-hand side are completely different. So there should be no solution to the system. Okay, so let's start by calculating the rank of the coefficient matrix. The coefficient matrix is 1, 1, 1 from the first row, and then 1, 1, 1 from the second row. These are the coefficients of the variables only. Okay, so let's calculate the rank of, I call this A matrix. So I calculate the rank of A matrix. I need the matrix package, and apparently I have it here. It actually happened to be a happy face, but supposed to be a blue button. It doesn't matter much because once you click on it, if it doesn't show the matrix menu, then that means you have to reinstall it. Okay, so then to reinstall it, you go to add-ins, and then select the package. So the address that I have is somewhere here. Okay, so this is the package that I have. Yes, reinstall it. Alright, so now I think this should be active. I click on that, I get this menu, yes. So I'm going to move it to somewhere here. I click on macros, matrix operations, and I'm going to calculate the rank, and to do the rank you have to do the SVD. So I'm going to click on SVD, I select my matrix, which is this 2 by 3, and then I want to see the SVD results starting from this cell down. I click run, and there you go. So I have 1 0 and 1 non-zero value. That means the rank of this matrix is 1. Okay, so let's have rank of A as of now is 1. Okay. Now, so the next thing we wanted to do is we're going to calculate the rank of A augmented with B, and the way we write it is this way. So we create a matrix with A, and then we put the B, the right-hand side of the linear system, on the right side and calculate the rank of that. Okay? And so to calculate the rank of the new system, I'm going to copy this over here, and I'm going to augment this with the B vector, which is 3, 4. I'm going to write 3 and 4 on column D. Okay, now this is A augmented with B. Okay, so I'm going to calculate the rank of this. All right, so let's go to the package again. And so I'm going to do SVD of now this matrix where I augmented A and B. And then the result is going to be in this cell. Okay, I'm going to click run. Now I get 2 non-zero singular values. So that means the rank of this is 2. Okay, so let me write the rank of right here maybe. I'm going to write rank of A augmented with B is 2. Oh, it's a typo here. Should have been A. Okay, so rank of A is not equal to rank of A augmented with B. That means this system is inconsistent. That means there's no solution. And this is clear because you have two equations. One has 3 on the right side, one has 4, and these equations on the left side are identical. There is no solution to this system. So if the rank of A is not equal to rank of A augmented with B, the system is called inconsistent, and there is no solution to such system. So that was section 3.74. Okay, now we're going to continue and do a couple more examples to see other situations. Like another case could be rank of A is equal to rank of A augmented with B, and both are equal to the number of rows in A, or the number of equations. Okay, so we already covered item 1 here. We found that if the system is inconsistent, there's no solution. I'm going to look at this case. Okay, so let me give you an example for item 2 here. And that would be if the rank of A is equal to rank of A augmented with B, and both are equal to the number of equations. Okay, so let's start with a system like this. So I'm going to go back to this spreadsheet. Let me move down a little bit. And let's start with a system of equation. I have 1 times x plus 2 times y plus 1 times z, that is equal to 1. Next equation is 1 times x plus 1 times y equals 1. The last equation, 1 times x plus 3 times y plus 1 times z is equal to 1. Okay, so let's create the coefficient matrix for this system. First equation coefficients are 1, 2, 1. And then the second equation coefficients are 1, 1, 0, because there's no z in that equation. And the coefficient for the third equation is 1, 3, and 1. All right. And my b is going to be, let me write b here. Well, let me hold on to b. Well, actually we can write it down, that's okay. 1, 1, 1. So this is the right-hand side. Okay, this part is A, and this is B. All right. So now let's calculate the rank of A. So I'm going to write maybe here, rank of A. Let's see what this is. So I need my matrix package again. I'm going to click on matrix operation, SVD, and select my matrix A, this 3 by 3. The result will go to this cell and run. Okay, the rank is 3. I have 3 non-zero values. Fine. I'm going to write it here. Okay. Next, I'm going to do rank of, so here's rank of A augmented with B. All right, let's see how we can do this. And this is actually supposed to be a vertical line. Oops. Like so. Okay, so now I'm going to calculate rank of A augmented with B. Again, go to matrix package, SVD. Now this time I'm going to click on A and B together. All right, so remember this B now is included. This is the last column here. All right, and then the result will go to this cell and then run. And this time I have also 3 non-zero singular values, and they're slightly different. That's okay. We don't care about the difference. So I'm going to write the rank of A augmented with B is 3. Okay. So I have rank of A is equal to rank of A augmented with B, and both are equal to 3 because I have 3 equations. And this is the case where we have a unique solution. That is corresponding to item 2 here. Okay, so these 3 are identical, and we have a unique solution. You can solve it by using the package again. Let's go ahead and solve it. I'm going to click on macros, matrix operations, linear system. Let's define our A matrix. This is a 3 by 3. I'm going to highlight that, and then my B matrix, or B vector, is going to be the last column. Click on that, and then let's say the solution. I'm going to put the solution, let's say here. Okay, and then click on run. The solution is 1, 0, 0, and that should be correct. Let's try it. If you plug in 1, 0, 0 in the first equation, you get 1. You plug 1, 0, 0 in the second equation, you still get 1, and you put 1, 0, 0 in the third equation, you still get 1. So that is correct. That means there is a unique solution. Okay, so we covered 2 cases so far. And the last case is if the rank of A is equal to rank of A augmented with B, but not equal to the number of equations. In fact, it can be less than the number of equations. So I'm going to give you an example for that case. So let's go back to our, let's say, a different equation. I'm going to close that. All right, so here is another example. So 1 times x plus 1 times y plus 1 times z, that's equal to, let's say 2. And my second equation is 2 times x plus 1 times y plus 1 times z, that's equal to, let's say 4. Okay? So now I have 2 equations and 3 unknowns. For sure, this has more than one solution because you have 2 equations. The number of variables is 1 more than number of equations. So you can fix 1 variable and solve for the other 2. So that tells you that there's infinite solution. Anyway, so we're going to do this using matrix package. Let's write the coefficients 1, 1, 1. And then 2, 1, 1. And then the B vector is going to be 2 and 4. If you do the rank of, so I'm going to do the rank of A. We're going to do SVD on A. So here's my A. And the result will go to this cell right here. So we see that there are 2 non-zero values here, right? So I'm going to write rank of A is 2. Let's do the rank of A augmented with B here. So I'm going to write rank of A augmented with B, right? Let's see what that is. So I'm going to go to my matrix package again, click on SVD. Now my matrix this time is going to be A and B together. And the result will go to this cell, and then click run. And this time, you see that still I have 2 non-zero values. That's okay. So we're going to have 2 there, right? So this is 2. And you see that rank of A is equal to rank of A augmented with B, but both are less than 3. I have 3 equations here. Sorry, I have 3 unknowns. And so 2 is less than 3. That means there's infinite number of solutions. Okay? All right, so now you know how you can define whether there's a unique solution, no solution, or infinite number of solutions, which is called n-r parameter family of the solutions. So in the next video, I'll be talking about how we can find the solution in the case that we have the n-r parameter family of solutions or their infinite number of solutions. So stay tuned and thanks for watching.